In this video, we're going to graph the curve y equals 1 over x squared minus 6x plus 11. Now, in order to do this, we can begin by graphing the curve y equals x squared minus 6x plus 11. It's often helpful to have x-intercepts, so to determine those, we can use the quadratic formula. We get 6 plus or minus the square root of 36 minus 44 all over 2. We recognize that we have a negative quantity underneath the square root. There are no x-intercepts. So instead what we'll do is we will convert this to vertex form. We can complete the square if we want. The number negative 6. If we divide it by 2, we get negative 3. If we square negative 3, we get 9. So we can say x squared minus 6x plus 9 minus 9, and then plus 11. That allows us to say x squared minus 6x plus 9. Whoops, this should have been a minus 9, sorry. Minus 9. Minus 9 plus 11, which would ultimately give us x minus 3 quantity squared plus 2. I used completing the square. You can use partial factoring or any other method. And so what we see is we've got a parabola with a vertex at 3, 2, and it opens up. So that's going to look like this. And we see here our next step should be to draw any vertical asymptotes where there's an x-intercept, but there are no x-intercepts. Our next step should be to go any point on that parabola where y is equal to 1 or negative 1, but there are no such points either. Now, we can see here that the curve y equals x squared minus 6x plus 11 has a minimum at 3, 2. Well, if I'm going to graph 1 over x squared minus 6x plus 11, I'm going to be setting up an inverse relationship, and so that minimum is going to become a maximum. Now, my x value of 3 won't change, but I'm graphing 1 over x squared minus 6x plus 11, so my y value will become 1/2. So what I'm going to have is a curve with a maximum value right there. Now, as this curve goes up to the left, the curve that I want to draw should be going down to the left, but it can't cross the x-axis. And as this curve goes up to the right, the curve that I want to draw should be going down to the right, but it can't cross the x-axis. So it's actually going to look like that. Okay, very thin curve. And so what we can do is we can say that our domain is the set of all x element of the reals. Our range is the set of all y element of the reals, so long as y is a quantity between 0 and 1/2. We can include the y value of 1/2 because when x is 3, y equals 1/2, so it's a valid y coordinate. But 0 is not in the range. The increasing intervals will be when x is anywhere in the interval from negative infinity to positive 3. We can put a round bracket on the 3, or we can put a square bracket on the 3. I believe you should put a square bracket there because of the definition of increasing and decreasing intervals. But the textbook doesn't put a square bracket, so I'll accept it if you don't either. Similarly, the decreasing intervals will be between 3 and infinity, or you can put a square bracket, like I actually think you should, on the 3. Now, when it comes time to talk about positive intervals, well, that's every x value between negative infinity to infinity is producing a y value that's greater than 0. Our negative intervals don't exist, and we can talk about our horizontal asymptote at y equals 0, and there are no vertical asymptotes.